Okay, class, picking up where we left off at. We have the slope as being -2/5 and our y-intercept is 7, or written as an ordered pair 0, 7. We plotted that point and now we have to do our rise over run. If we make our rise negative, we will go down 2 and then we will go to the right 5. But if we make our run negative, that means from this point here we will go up 2 and to the left 5. And now we need to draw the line. And the line is represented here. Now we scroll down to the next problem. It says graph the linear function y equals 4/3 x minus 2 by using the slope and y-intercept. This is already in slope-intercept form, so the slope here is 4/3 and the y-intercept is -2, or we will write it as an ordered pair 0, -2. Now we will graph 0, -2, go to the origin, go down 2. And then now we have to do the slope. Our rise is +4, so we will go up 4. And then we will run 3. And plot our point. Now we could do that again. We'll rise 4 and run 3. And now we will draw our line, which we have here. This is my line. Okay, now we scroll down. We have our next example. It says, given the equation 4x plus 3y equals 12, using slope-intercept form, we have an a, b, and c. First, with a, we want to put the equation in slope-intercept form by solving for y. So we can go off to the side here and solve for y. We'll subtract 4x on both sides. We add 3y equals -4x plus 12. We divide each individual term by 3. And y is equal to a -4/3 x plus 4. Now this would take care of A. Now we want to do B. Identify the slope and the y-intercept. The slope here would be -4/3, and we know the y-intercept would be 4, or written as an ordered pair to be 0, 4. Now for C, we want to graph it. So now we put in the ordered pair, which is 0, 4, the y-intercept. Now we do our rise over run. If we leave our rise negative, that means we will go down 4, and then we will go to the right 3. Now we could do that again. We can go down 4 to the right 3. Now the reason why I was able to do that with this problem and not the others, because the numbers were small enough and the point was positioned in the correct position. So now let's draw our line, and here's my line. Now we scroll down. It says equations are horizontal and vertical lines. Horizontal lines. If a line is horizontal, its slope is 0. The equation y equals mx plus b becomes y equals b, where b is the y-intercept. All horizontal lines have equations of the form y equals b. Vertical lines. If a line is vertical, its slope is undefined. M is undefined. A vertical line does not represent a linear function because it does not pass the vertical line test. No vertical line represents a linear function. All other lines are graphs of functions. All vertical lines have equations of the form x equals a. In summary, equations of the form y equals b are horizontal. Equations of the form x equals a are vertical. The graph of y equals b, or f of x equals b, is a horizontal line. The y-intercept is b. The graph of x equals a is a vertical line. The x-intercept is a, which we see here. Now example, graph y equals -4 in the rectangular coordinate system. So what we would do is we would go on the y-axis to -4, plot our point, and then we would draw a horizontal line, which we have here. And remember, we must have those arrowheads. That means they go on forever in both directions. Now we have graph x equals -5. Now if we go here, we go on the x-axis to -5, 1, 2, 3, 4, 5. So we go 5 to the left, and then we would draw a vertical line here. And here's my vertical line. Now, we scroll down. It says graph x equals 2. So we will go to where x is 2. Then we would draw a vertical line. And here's my vertical line. It doesn't matter the length per se, as long as I have the arrowheads and it includes this point, the initial point. Now we want to graph y equals 3. So we would go up to y is 3. Plot that point and draw a horizontal line, which I have included here. Now we scroll down to the next page. Now we come to slope as the rate of change. Slope is defined as a ratio of a change in y to a corresponding change in x. Slope can be interpreted as a rate of change in an applied situation. Modeling data with the slope-intercept form of the equation of a line. Linear functions are useful for modeling data that fall on or near a line. Example, the graph shows cost of entitlement programs in billions of dollars from 2007 with projections through 2016. Now we see here, it says find the slope of the line segment representing Social Security. Round to 1 decimal place. Okay, so now we look here at Social Security. Now all we need is 2 points, and we have that. We have 2007, we had 2016. So we had 2007, 582. There was 2016, 970. Now we use our same slope formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So 2016 minus 2007 is 9. 970 minus 582. We can go off to the side here. And of course, so this will be 8. This will give us 388. Now, what you would need to do is take your calculator and divide this out, which I will use this calculator here. We had 388 divided by 9, and that gives us 43 point, and you see it's a lot of ones, and they want us to round to 1 decimal place, so it'd be 43.1. And this is the final answer. Now describe what the slope represents. Now we know the slope represents a rate of change. So this represents the rate of change for entitlement programs will be $43.1 billion per year from 2007. Now we can look down here. We have our solution. Now this is our handwritten solution. This is the typed solution. And you can feel free to look at this at your leisure. And you can pause this video. And here it is. And we are done.